Welcome to today's VF reminder. We are about to continue high lift devices lesson, and more particularly leading edge and the combination with trailing ones. Two kinds are existing, leading edge flap and leading edge slot. First, leading edge flap. Since leading edge of high-speed airfoil has a little camber and a small radius, the flow separation may be located just after leading edge at low angle of attack. Leading edge flap will improve leading edge camber. Its main effect is to delay separation, leading to increasing stalling angle of attack and the maximum lift coefficient. Leading edge slots is a gap from the lower to the upper surface of the leading edge. It is created by a fixed or a moving part, the slat. Thanks to this gap, airflow at high pressure of the lower surface reaches the upper surface, where pressure is lower. Boundary layer is re-energized due to this kinetic energy addition. As a consequence, boundary layer separation is delayed to a higher angle of attack. If the slot is fixed, it will create an extra drag at high speed, so we prefer to use slats. We can notice that maximum lift coefficient is higher. This is a consequence of a marked camber. We can notice that pitch moment is insignificant when the air actuated. It seems that slot is far most interesting than trailing edge flap because of a better maximum lift coefficient obtained at a higher stalling angle of attack. But, when you are in landing phase, such an angle of attack will reduce visibility. However, pitch moment and drag generated by leading edge devices are lower. To take a maximum of benefits from these devices, let's consider a combination of them. But, we have to think about the sequence of operation. Lowering trailing edge flap increases downwash and upwash, so for a high-speed airfoil at low speed meaning high angle of attack, such an upwash at the leading edge can lead to the stall. Therefore, we need to lower leading edge device then trailing edge 1, and for retraction, trailing edge has to be retracted first. And now, how may we choose flap configuration for takeoff, climb and landing? First, for takeoff. Takeoff distance depends on unstick speed and rate of acceleration to this speed. The lowest unstick speed is obtained for the highest maximum lift coefficient, so at the largest flap angle. But a large flap angle is creating an important drag, and acceleration to that speed will be reduced. As a consequence, choosing a lower flap angle will give a better acceleration and a lower unstick speed. This is a compromise to optimize. Since leading edge flap increases maximum lift coefficient without generating too much drag, they will be deployed for any trailing edge flap configuration. For the climb phase now, remember that lift to drag ratio is decreasing with an increasing angle of flap setting, leading to a lower climb performance. In case of climb gradient limitation, choosing a lower flap configuration, even if takeoff distance is increased, may be selected. In an operational way, we have to think about the distance of the obstacle. If the obstacle is close, prefer a higher flap configuration so the aircraft will be airborne earlier and climb earlier. If the obstacle is far, prefer a lower flap configuration to prefer a better climb performance. Now, let's talk about landing. Landing distance depends on touchdown speed and deceleration. The lowest speed is obtained for the highest maximum lift coefficient, so at the largest flap angle. The most important drag, and so deceleration, is also given for the largest flap angle. So we may use large flap angle for landing. If leading edge devices are fitted, they are also deployed since they increase maximum lift coefficient. Operating high lift devices generate multiple aerodynamic changes, so the pilot needs to properly manage retraction and extension. Just after takeoff, you will need to retract flaps. Aircraft is in state I. If you retract directly flaps, meaning at same angle of attack, aircraft will sink because of a sudden loss of lift. The good management should be to first rejoin B, by decreasing angle of attack and accelerating. After this, you can retract flaps to get C position, while you are increasing angle of attack to keep a sufficient lift. Note that drag is decreased from B to C so the acceleration capability is improved. If acceleration is low during flap retraction, angle of attack must be increased to avoid sinking, typical phenomenon at heavy weight and high density altitude. And now, for landing, you need to extend flaps. From position I, if you only extend flaps, while maintaining the angle of attack, the lift will increase and you will gain altitude. So, you have to rejoin B position by extending flaps while decreasing angle of attack in order to maintain constant the lift coefficient. After this, you can decelerate and increase angle of attack to be in C position. Well, that's it. Challenge yourself on the Instagram profile. And do not forget to subscribe if you have liked this video, so you can be advised when new ones will rise.